And this is MAP4C day 24, lesson 3.3, day 1, and we got a big 3-minute review. The goal from last day is interpret graphs to describe a two-variable relationship, and we've got one here. We see the two variables are age and books read. The first part was to decide which is the dependent and which is the independent variable. First thing in the table is independent, right? So age is the independent variable, and books read is the dependent, which also means that if we're to do a scatter plot, and looking ahead, I think we have to, that age is going to go down here, first thing on the table goes on the bottom, and books goes on the side. Would you suggest this is a positive correlation, negative correlation, or no relationship? And it's hard to see from the table, but we kind of have to just think about this. You know, as people age, and we always think of the independent variable increasing, so as age increases, what happens to the number of books people read? Books read, and then you'd fill in this. And that this is kind of opinion, right? One might think that you have to read more for school probably, so it probably books read increases. But then another person would argue, you know, when you're little, you're young, small age, the books are really tiny, so you fire through them pretty quickly. But we'll see the relationship. And these are just all, you know, high school age kids anyway, so create a scatter plot. So let's do that for this data and try and do this fairly quickly. Of course, you're going to fast forward. You don't have to watch me do your scatter plot. As far as picking a scale, that might be the toughest thing. You know, I'm going to make a little break in the graph there. We start at and go as low as 14. We have to get up to 18. So we want to use a decent scale here. And this is kind of up to you as well. You don't have to use the same scale as me. And I like using as much graph as I possibly can. And notice I'm going to have to kind of extend a little bit there. That's up to you. You could have used each 3 ticks is worth a year when we're not in between. And I've got a break in the graph, right, to show that I'm not starting at 0. As far as books read, I see that I've got a low of 3 and a high of 15. I might as well start at 0 and try and go up to 15. And I won't quite get there, but I'm going to go up by 1 book each time. And then, you know, 15 is going to be over here somewhere. This is title, books, and age, or something like that. And we're going to do some, draw the scatter plots. 16, 5, 15, 3, 18, and 8. Hard to draw since it's off the graph, but that's not so bad. 17, 6, 16, 4. $17 and $50. And that one's way up. That's the kid who really likes to read. And there's our scatter plot. Today what we're going to be talking about is drawing a line of best fit, or a trend line. It says an outlier is a point that lies far away from the main trend. Well, guess who that is? This person right there, right? Outliers, if valid, not just a measurement mistake, could be considered in the overall trend. What I mean by measurement mistake, let's say this person actually only read 5 books, but somebody goofed and wrote down 15. Right? That's a question we have to ask ourselves, is whether that was a mistake or whether it was actually somebody who read 15 books. And if it was not a mistake, that person should be considered in the overall trend. Although everyone else follows this nice even trend, this is this outlier should be included. All right, let's keep going. The second goal is to write the equation of a line given a graph. So here's a graph, and so this is a little bit of review of grade 9 and 10 stuff. Equation of a line, y equals mx plus b, right? And if we want to go from the graph, these 2 points are kind of written here, right? So I'm going to write them on there. 420 and that's 9, 12, 12, 30. And then I've got to be able to figure out what m and b are, so I'll have an equation. Right? Well, the slope, there's a couple of ways to get slope. Rise over run, which, if you had a graph, I suppose you could just put in a little triangle there and figure out what the run is and what the rise is. More often, we're grown-ups now, we're going to use y2 minus y1 over x2 minus x1, where these are the values of x2 and y2 and all that business. So so this is x1, that's y1. This is x2, and that's y2. And again, x coordinate, y coordinate, x coordinate, y coordinate, and then I can fill in the slope. You might remember some other ones like change in y over the change in x. All of these work, whichever one you like the best. I like this one mostly because it works all the time, not only if we're given a graph. So y2 is 30 subtract 20 over 12 subtract 4, 10 over 8, which is about, no, it's exactly 1.25. Get rid of that little dot there. Okay, so that m is 1.25. Now, what's b? Well, remember, b is the y-intercept. And in this case, because we don't got any breaks in the graph, we got nothing going on here, we can actually read the y-intercept from, or at least it looks like it, right? It's hard to tell sometimes, but it looks like the y-intercept is 15. So I could combine my slope calculation with the y-intercept that I read from the graph, and then there's the there's the equation, right? This should be 15 here. That's 15, and there's the equation. Now, I am going to go through the process. What happens if we can't read this off? Like if there's a break in the graph, either graph or it's in between dots or whatever, we might want to calculate the b value exactly. So what if we can't see b from the graph? Well, we can calculate it. And you learned this back in grade 9 or grade 10, I think. And so we've got the slope still. We calculated the slope using 2 points, but let's say we couldn't see that it was 15. Well, just use one of our points, and it doesn't matter which one. If that's x and that's y, that gives me a specific value that's on the line. So I could put in y is 20, x is 4, and then I can calculate what b is. Subtract 5 from both sides. A little bit of algebra work doesn't hurt us, and then there we've got it. B is 15, so therefore y equals 1.25. X plus 15 is the required equation. ITRE is the required equation. Big 3-minute review, but actually that's a lot of today's lesson, so let's keep going. So line of best fit, which is a little bit of a review from grade 9, but we're going to try and go through pretty fast, and it's going to be real numbers, and we're going to run into some problems, grade 12 type problems. So Market research has provided the following data of the monthly sales of a licensed T-shirt for a popular rock band. And this is a Winger T-shirt, by the way. Look up Winger from the 80s hair band. Good, clean fun right there. And then let's draw the scatter plot. Again, you don't have to sit and watch me draw my scatter plot. And you don't have to use the same scale as me. Let's see, I could use a break in the graph, but it's only at 10 anyway, so I'm gonna go up by 2 each time here. So that's 10, 2, 4, 6, 8, 10, 20, 30, and that's price, right? First thing in the table goes along the bottom. That's the independent variable. Monthly sales. And I got to get all the way up to 2,500, and there's some low numbers, so I'm not going to use a break in the graph here. Maybe I'll go up by every 4 squares is 1,000, so every single square is 250, and I see a 250 there, so that's going to work out nice. This is T-shirt sales title, and again, you don't have to use the same scale as me. All right, so $10, 2,500 would be right there. That fell on a nice point because it's right there. 12 and 2,200. Each square's worth 250, so it's a little bit below there. Right there. 16 and 1,600. 1,500 would be there. A little bit more. 18 and 12, a little bit less than that line right there somewhere. And I'm just guessing, right? I'm just putting them as close as I can think to. 800, the 750 would be there, so a little bit higher than that. 2200, 22 and 250, 22 and 250. Okay, so we see this is a negative correlation, right? It says draw a line of best fit that models the relationship. And you've had some practice doing this, but the idea, and I'm going to do a bad version to begin with and then mess around with it. See, the idea that you talk about is so half the points are above and half the points are below the line, and it's got to follow the general trend. So for instance, you know, there, this line here has got 3 above and 3 below, but it doesn't follow the trend, right? Neither does neither does this line. That's silly, right? So we want a trend line that's going to follow the trend line and go through as many points as possible, and half the points above and half the points below. Okay, so something like that's not bad. This is going through almost all of them, isn't it? And of course, this takes a little bit of practice. A way to help yourself, and this seems to help, is you draw a tight loop. No, it's not tight enough. A tight loop around all the points. And you'll get some sort of face or cigar shape. And then your trend line should cut that cigar shape right in half. Okay? So those two are done. Draw a line of best fit that models the relationship. And we can see it's a negative correlation. Calculate the equation of your line of best fit. See, now we're talking. Y equals mx plus b. Where we want to pick 2 points that are on or close to on our line. And I could pick, dots that were in the table, or I could pick nice points that are on the graph. So for instance, this looks like a spot where it crosses on the graph paper, right? That point right there, which is 18 and 1,000, appears to cross on the graph paper. Maybe we would want to use that point. Where's another point? Here's a point that's on the graph. This one is 10 and that was one of our plotted points. Do we have to use plotted points? No, not necessarily. This one, for instance, isn't quite on the line. Maybe I'd want to pick 2 that are on the line, and that's kind of up to you. but I'm going to use these 2 points. The slope is y2 minus y1 over x2 minus x1. And again, does it matter that this is x1, y1, and this is x2, y2? Not really. These could be switched if you want. 1,000 is y2, subtract y1, which is 2,500, over x2, which is 18, subtract 10. That looks like negative 1,500 over 8. And that makes sense. The slope should be negative because it's going downhill. And we could put that into a calculator and get a number. I bet you it goes evenly, or pretty close anyway. So it looks like around negative 187.5. And notice that if you pick different numbers, your slope's going to be different than this. Okay? All right, so M is negative 187.5. So notice what that means. Every dollar that I raise the price, I'm going to lose $187 in sales, right? And that seems to be the trend. Our B value. Notice this is one where if I extended this line, if I extended this line back this way, I might be able to get a value there, but that's pretty tough. I'd have to extend this. I'm going to actually calculate this, which will take some room up, and I'm running out of room, but that's okay. 87.5 x plus b, and I'm going to use one of my points here, 2,500. Change my pen, get it a little bit smaller. Negative 187.5, and x was 10 plus b. That's a nice value. You can do that in my head. Plus b. And then I got to get rid of that, so I'm going to add it to both sides. Add it to both sides. And that is, on my calculator, 4375. And that's a bit of a mess. That's plus sign. 4375, and that's B. Notice, would that make sense if I extended this? If I sort of went, oh, there's 3,000, 4,375, I think I could convince you that. So the equation is, now, through my rough work, 4375. And we want to predict the sales if the shirts are priced at 19 bucks. Notice that one way is to just use the graph, right? And it looks like if I just use the graph and bounce off my line of best fit, it's around 950. 950 from the graph. But I'd say, but I can be better than that, can't I? I can use my equation. The x value is 19, so I could use my equation and make a prediction. This goes into a calculator. 19 times negative 185.5 plus 4375 is about 812 on my calculator. So, and that's in the ballpark there. I know it's more than 750. 112.50, and I should have a sentence. Okay, I'm going to check my time and see if I got. I should pause. Feels like it's getting long, and it is. I'm going to pick it up in part.